All right, so with question number 3, we are solving the system by substitution. And what we're really trying to find here is the point at which these two lines intersect. So with questions 1 and 2, we were given two equations, just like we are here, but we were also given a point and asked to test that point to determine whether or not it was a solution. So we were given a point, whereas in this case, for 3, 4, and 5, we are going to be asked to find that point, the point at which these two lines intersect, via substitution. So let's go ahead and do that. And when we're solving by substitution, the first question we want to ask ourselves is this. Is one of our two equations already solved for x or y? Or is one of the two equations easily solvable for x or y? And while neither one of our two equations here is solved for x or y outright, we can solve for y rather easily here with equation number 1. And we can do that by simply dividing by -1. Or of course you could multiply by -1. You'll get the same result. And that result is simply a positive y equals now -3x plus 13. So the first step you want to do is take one of your two given equations and solve for x or y. And once you've done that, just like we've done here, you're going to take that result, in this case y, and plug it into the equation that you did not solve for, wherever you see that variable. And so in this case, we took equation number 1, solved for y, and so now we're going to take this result, the -3x plus 13, and plug it in for y into equation number 2, the equation we didn't use. So what does that look like? Well, we have 2x plus 9, and now we're taking this y out and plugging in our -3x plus 13, because that's what we're saying y is equal to. So -3x plus 13 equals -8. And now let's go ahead and clean up the left and try to solve this like we normally would. So we'll go ahead and distribute this positive 9 through. So we have 2x plus, well, 9, positive 9 times -3x is going to give us a, negative 27 here. So minus 27x. And then a positive 9 times positive 13 gives us a positive 117, I believe, equals -8. And now let's go ahead and combine some like terms here. So we have positive 2 minus 27x, so that's going to give us -25x plus 117 equals -8. And now since we're solving for x, let's go ahead and move this 117 over, and we'll subtract it from both sides. And so now we're left with -25x equals, well, -8 minus 117 gives us a -125. And solving for x, we'll divide by -25 on both sides. And that's going to leave us with x equals positive 5. All right, so now that we've solved for x is a real number. It's no longer in terms of another variable where we have one variable equals a number. Let's take this result now and plug it in to our first equation here that we manipulated and solved for y, because as soon as we take this x value, plug it into our -3x plus 13, we'll have the y value. You could, of course, take this this x equals 5 and plug it into one of these two equations, but you would have more work to do because you would have to go ahead and do some additional algebra to solve for y, whereas here we already solved for y. And so let's go ahead and take the easy road and go ahead and plug it in so that we know what y is right off the bat as soon as we solve. So we have y equals -3. Now let's plug in this 5 plus 13. And so we have -3 times 5 is going to give us a -15 plus 13. And of course, -15 rather, plus 13 is going to give us a -2. So y equals -2. And now we've solved. We have an x, we have a y, so let's go ahead and write this as an ordered pair. So 5, -2, and this is now the solution to our system. And so if we graphed each of these two lines, we would see that the two lines here intersect each other at the point 5, -2. And on a test, if you are finished early, you can go back and actually check yourself and just make sure that indeed 5, -2 is the solution by doing what we did in questions 1 and 2. So take this point that you found, plug it into each of your two equations, and you should get a true statement. And that's a way you can check yourself on a test. Let's go ahead and take a look at question number 4 in our next video.